In this video, I'm going to show you operational amplifier inverting negative level detector circuit. Why this is called a negative level detector. This circuit is also an operational amplifier comparator circuit in which we will apply a input voltage Vi and a reference voltage, but this time we will apply a negative reference voltage and in the non-inverting terminal. As the reference voltage is negative, that's why this is called negative level detector, and this is called inverting negative level detector because we are applying the input voltage at the inverting terminal of the operational amplifier. See, there is no direct connection between output and any of the input terminal. So this is an open loop operational amplifier, in which case I can write output voltage VO equal to open loop gain A into input voltage difference VD. VD is the voltage difference between this non-inverting and this inverting terminal. So what is this VD? VD is the voltage difference between this and this terminal, and this terminal has a voltage of minus VREF, and this terminal has a voltage of, here we are applying triangular waveform, this terminal has a voltage of minus VI. Now consider two cases when our input voltage VI is greater than our this negative reference voltage VREF. This input voltage is greater than this negative reference voltage. As this term is greater than this reference voltage and this is also another negative term, therefore our voltage difference VD will be more negative, and when we multiply this input voltage difference with the high gain of operational amplifier 10 to the power 5 to 10 to the power 8, then our operation, as this is negative voltage difference, therefore our operational amplifier will operate into negative saturation region. Second case is that when this input voltage Vi is less than VREF. If Vi is less than the negative reference voltage, that means this input voltage will be more negative with respect to this negative reference voltage. As this input voltage goes negative, therefore there will be a minus sign in front of it, which will in turn make our this minus sign will be multiplied with this minus sign, which will make this VD positive. So I will get our positive difference voltage difference plus VE, and our output voltage, when this voltage difference is multiplied with this 10 to the power of 5 to 10 to the power 8 range, it will operate in the positive saturation region, and the positive saturation voltage is controlled by our positive power supply plus Vs. Now let me show you the input and output characteristics of this negative level detector circuit. Our operation was like this: when Vi greater than our negative reference voltage, VO was in negative saturation, and when Vi is less than VREF, that means Vi is more negative than this negative reference voltage, our output voltage will be plus V set. From this point to this point, see, this is our applied triangular waveform Vi. Within this interval, input voltage Vi is obviously greater than this negative reference voltage. When Vi is greater than negative reference voltage, our output voltage will be in negative saturation region. See, from this point to this point, our output voltage VO is in negative saturation region. From this point to this point, up to this point, this input voltage VI is clearly more negative. That means this input voltage is smaller than this reference voltage. Therefore, within this interval, our output voltage will be plus V sat. From this point to this point, input voltage is again clearly greater than this reference voltage. So within this interval, our operational amplifier will be in negative saturation, and when this input voltage crosses this negative reference voltage again, there will be a transition of output voltage from negative to positive saturation. So this is the input, this is output, and this is input waveform of negative level detector circuit. Now let me show you the transfer characteristics of this inverting negative level detector circuit. See, this is the point where we take the reference. This is our input voltage axis Vi, and this is our output voltage axis Vo. The points that are lying to right from this point, in that case our input voltage Vi is greater than our negative reference voltage. When input voltage is greater than reference voltage, our operational amplifier will be in negative saturation. When our input voltage Vi is less than the points that are lying in the left, from this point our input voltage will be less than our negative reference voltage. That means input voltage will be more negative from this negative reference voltage. In that case, our operational amplifier will operate in the positive saturation region, and the positive saturation region voltage is controlled by, or will be equal to plus Vs, nearly equal to plus Vs, and the negative saturation voltage will be nearly equal to minus Vs. Okay, that's it. Thank you.